Let's turn off video capture. Okay. Is that working? I think that's working. That's showing up for you? Okay, cool. All right. Yeah, so quickly, a little bit, go over the calendar. Okay, so you all presumably did pretty well on midterm 2. And if you didn't, it's my fault because I had to fix the instructions. So that is not something for you to worry about. Separately, last week, there wasn't a homework because there was midterm preparation. We're back into our homework era. We're homework maxing. It's giving homework, right? And so since it's giving homework, I'm going to go over the next homework today, which is Enigma. I have slides, and then I also have the project description, but I think I'll go ahead and grab the project here. Hopefully that works. That link is not posted. That's crazy. Okay. I will post it immediately after class. Hold on.
Question mark.
Well, I made it yesterday. The website blew up over the weekend, which is another reason I'm not doing things. So let's see if any of you have started it yet. Nope, you're all slackers. Okay. I don't feel like that would stop you. We're going to go ahead and throw this in Discord for now in case you want to follow along during class. And then I'll get it posted. What class is this? CS 151?
Maybe.
The first assignment named after a DC Comics Batman villain, Edward Enigma. Okay, there we go. Okay, so we got that. Okay. Someday I'll figure out who's responsible for my website. Okay, and then I'm giving Wednesday off. I could have found a guest lecture. I would actually rather you spend that hour working on this project. So, if you want to, I could have a TA here for 1 hour and you could have a work session, but you have to ask for that soon. Or you can all show up and help each other. I don't care. Friday is definitely not teaching machine. That lecture is going to change based on how I figure out how to do the final project in this class, because that lecture is to get ready for the final project. So there's going to be something else happening on Friday. What is it? Probably JSON, which is a file format. We'll find out when we get there. Then I'm going to introduce Adventure, which is the final project, a week from today. And then we don't use this anymore because we changed the final project. We don't use this anymore because we changed the final project. These were free bonus lectures. What's going on for the rest of the term? I don't know. It's going to be crazy style, right? We're going to do stuff, right? I just realized I don't have my cuffs connected. That's how crazy it's going to be, right? So today we'll introduce Enigma, and then it's crazy style from here on out.
Cool. Is Enigma due in a week or 2 weeks?
It's due in 1 week, I think, which I did not know that. I thought it was due in 2 weeks. So now I'm stressed.
Yeah.
Yeah, because I have to do it. That's not true. I did it last year. And the year before that. But, okay, so here's Edward Enigma, right? Classic. This is going to give me a... Okay. I'm accepting the assignment. Blah, blah, blah. And then we will open the slides for today as well. Is this thing ever going to load? No. Okay. Cool. What did I just click? I'm clicking things. Never click anything. Do as I say, not as I do. Right? Okay, it's easy. Okay. Midterm sketch, project 5 postage, guest lecture Wednesday. All of those things are false. Okay. So, Enigma. We're doing a little bit of cryptography. Usually cryptography I think of as being done with numbers. Doesn't have to be. You can do it with just letters. This is going to be letter-based cryptography. Specifically, we're going to do a couple things with the alphabet. So that is going to be 26 English letters, or I think the characters might be called the Latin characters. But we're just going to do the 26 that are used for English. I'm going to teach you about rotations and ciphers, and then we're going to go over the starter code. So this is just a bit of a theoretical background. to set you up for the project. Okay, so the essence of P4, which is Project 4, Enigma, is cryptography. I'm going to introduce some terminology. Why am I doing this? I'm going to have to talk a lot today, and I'm going to have to describe things. And so I'm going to define terms so that I can say the term and we know what it means. Encryption is the act of encrypting something, so encrypt is a verb. Encrypt, it's what you think. You take something and then you make it cryptid, right? Cryptic. So how do I usually describe that? Well, I'm going to take a plain text and then I'm going to produce a ciphertext with encryption. I'm even gonna write this on the board, right? Okay.
Whoa.
That's not that low.
Handwriting.
And then so there's going to be an arrow here, and what is this arrow? This is the encryption arrow. And then you're going to get a ciphertext. Why do we call it plain text and ciphertext? Well, they're both text, and we have to give them both a nick. So plain text is stuff you can read, and ciphertext is stuff that you can't. That's all. So we can do a quick example here. Let's open our favorite code that starts with VS. And we'll write an encryption function. What's this one going to do? Okay, we're going to take a string, and we're going to make a string. Okay. So we're going to def encrypt. I'll just take my plain text. And where do you keep your plain text? At your airport text. Okay, all right. That was a good one? No? Okay, all right, fine. Okay. Then I'm going to create a ciphertext. I really feel like y'all are sleeping on how funny airport text was. That was pretty good. Okay. Not like my best by any stretch of the imagination, but... So planes live at airports? Yeah, right? They have to live somewhere. The variable name ciphertext is doing absolutely nothing here. I just had to label it so you can see. So let's encrypt something. Usually I pick one of my more embarrassing secrets. Let's see, do I have an embarrassing secret? So my secret is I had a bag of Lay's potato chips for breakfast, which is not a well-balanced breakfast. That's why it's embarrassing. Okay. Bag of Lay's. Okay. And then what am I going to do? I'm going to print my secret out. Usually you skip this step when you're trying to keep it secret. Then I'm going to make my cipher, which is going to be, and I'm going to encrypt my secret. And then I'm going to print out my cipher so we can look at all of them. And for those of you that are into such matters, yes, cipher is the name of a character in the matrix, okay? All right. So I can take bag of Lay's, which is possible to be pronounced, and is and get back .cialfogab with like an emphasis on the B, right? And that's not a meaningful sentence, but it's also not particularly secure. So this is just a sort of minimal example of what I mean by plain text you would expect to see. Ciphertext looks like nonsense, but there's still information in it. Reversal is a little too boring and a little too easy. Why is that? Well, here's something I can do. Why don't I just take the cipher and we'll just print it again, but we'll encrypt it first. Okay, so I'm going to re-encrypt. Spelling is challenging. Cipher. Wow, I'm not even close. Cipher. I promise my brain was working just earlier today. I don't really know what happened to it in the last, 4 minutes. Okay. So one of the problems with a sort of reversal encryption is that it is very easy to undo. So it is perhaps not particularly secure. So if I just double encrypt something, encrypt, secret, I just see the secret back again. So we're going to use a different technique other than just reversal. We're going to use a rotation, but as I say that, I'm going to be a little careful with my terminology. When I had a reversal to do an encryption, I reversed the string itself. when I do a rotation, what I'm actually going to do is I'm going to rotate letters within the alphabet. So I'm going to take a letter and I'm going to move it forward or backward through the alphabet by some amount. And this is still reversible, but it can be much harder to read. So how am I going to do this? Basically, I'm going to take a look at enumerate, and I'm also going to take a look at the alphabet. So how are we going to do this? I'm actually going to quickly write the alphabet because I don't want to type it a bunch of times, so I have to call this thing ABCs. And now I'm going to try and type the alphabet. I'm going to do caps lock, which is cruise control for cool. Okay, no, that can't be right. J is before K. L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z?
Yeah.
Yeah? Now I know my ABCs. They call that going ABC style. Okay. I'm sorry, no one actually calls it that. Okay, and so what are we going to do? Oh, I still had cruise control on. For the index and the character in enumerate, ABCs, what does enumerate do? It's sort of the combination of taking range length and then also for I in. So we're going to enumerate over ABCs, and then we're just going to print I and C. And so it is relatively straightforward to give every letter in the subset of the Latin characters used by the English language some number. And these numbers range from 0 to 25. So we can rotate letters within this in a variety of ways. So let's take a look at a sort of minimal rotate. This is going to take a letter, and it is going to return a letter. So I'm going to do a single letter rotate. And I'm going to specify this as a single letter rotate. It takes a letter, and it returns a letter. Okay? So, to begin, we'll just pass this, and then nothing will happen. Okay, cool, that was fun. All right, whoa, scary. Get rid of this, or I'll just comment it out. Maybe we need that later for something. Okay, so how am I going to do this? To go from, for example, A to D by rotating 3 forward, we start at the input letter, A, and then we count forward in the alphabet, and we say, okay, I'm going to start at A, and then I'm going to go B, C, D. So a 3 forward rotation on an A returns a D. Okay? So all I need to do in rotate is do that same process. So how do I do this? Well, the first thing I'm going to do is I'm going to introduce the dot index method. Dot index method is a string method, and I don't believe we've seen it previously. But, for example, we can, instead of doing for I, C, and enumerate ABCs, which let's run that again, we get these values. We can instead ask for C in ABCs. And then instead of printing I, we can say ABCs.index C. And this will tell us the position in the ABCs of some letter. So we're going to use dot index to do that. So in my rotate, what I'm going to do, the first thing I'm going to do is I'm going to find I, and it's going to be ABCs.index of letter. Okay? And this code still runs. There's nothing broken about it. Okay? In the Enigma code, we give you the ABCs. We just call them the alphabet. So you are encouraged as well as able to use the alphabet on the next assignment when you are doing something similar to this. Okay? So, what are we going to do next? Well, after we get the index, we have to do something with that index. And what do we have to do? We have to do some sort of rotation. So I gave the example of a rotation of 3 that's going to rotate A to B, C, D. Right? So, how do I do that? Well, I take I, and I'm going to add 3 to it. And then what am I going to do with that? Something that is not terribly complicated. I'm going to look up in the ABCs what that letter is. We're going to add 3. How's that going to work? You can do, okay, yeah, I just did plus equal 3. That's fine. I don't know which one of these is more clear. So, however you want to add 3 to I, it is up to you, right? And then all we have to do from there is look up the letter in the alphabet. So let's go ahead and do that. We'll return ABC's I. And then let's check. Let's print a rotate on A. And I can't just put A in there. I have to put A inside quotes. We'll block this out again. Let's see. I'm going to indent this. And I'm just going to put an if statement here so I can turn it on and off more easily. Okay. So when I run this code, and let's split my screen a little bit better here. I understand there's 4 boxes on my screen, and you're encouraged to look at all of them right now, right? Okay. In order to rotate a letter, I'm going to find that letter's index in the alphabet. I'm going to add 3 to that, and then I'm going to return that value. Okay, and so A becomes D. What does J become? This is not an extremely difficult thing to figure out. Okay. Talk to one of your friends and pretend you were paying attention so far today and figure out what follows J if we perform this rotation on it. Maybe. I selected J because the 3 letters that follow it are the name of a Dutch airline, which is a playback on our planes airports thing. Okay. All right, get your final answers in. Pretend I'm Regis Philbin and you want to be a millionaire. Okay. Okay, it's M. Good job. Okay, now it's time for an emergency pop quiz. What happens if I put Z in here? Okay, yeah, what happens?
Does it break?
Yeah,
Go to B.
it explodes.
Yeah.
We did something silly. Yes, it's true. It's true. We have to do our least favorite thing, modular arithmetic.
Our most favorite.
It's our most favorite thing, modular arithmetic. Okay, blink once if you're under duress. Okay, and why is this? Well, no problem. Let's just let's see what I is. Okay. So that's a 28. Folks, there aren't 28 letters in the alphabet. You're cooked. So what do we do instead? Well, in theory, I think probably what you want to do is loop back around, right? Because currently we have no way to express A. So what we're going to do is we're not going to do modular arithmetic. If I is greater than 25, we're just going to subtract 25 from it. And then it's going to work.
Whoa.
Wait, did it? That's D. That's still a little bit cooked. Do we subtract 24? Nope. Do we subtract? Oh, because there's 26 letters in the alphabet. Folks, I just remembered there's 26 letters in the alphabet. And actually, you don't have to do that. You can just do len ABCs. This is the way to not forget. Boom. Oh wait, why is that 25 in there? Why is that? That's a little suspicious. Shouldn't that be greater than or equal to the length? Oh, that's still looking pretty good. Oh, I bet we should make sure our code works by putting Y in here. Tell me why. Okay, yep. And so what's the B stand for? It stands for the Backstreet Boys, right? Okay. Even though that was NSYNC, wasn't it? Which one of you was alive in 1998? Okay.
We are all new millennium children.
Are your children of the new millennium?
Children of the new millennium.
Interesting. Isn't the millennium a social construct?
What is it?
And
Gravity?
we are children of that social construct.
Aren't children a social construct?
That's it.
That's not that much of a reach. Okay. All right. So anyway, here's your rotation. And then if you're a fancy person, right? So some of you may have noticed there's a bunch of math majors in here that routinely make their presence known, right? And we love them for that, right? This is a math major positive classroom. which I didn't know how math major positive it was until we all got here. So you can add 3, and then you can in fact do a mod. Okay, it's allowed. You have to put it in parens. I think this probably works. I don't know. I'm not a math. That's not true. I am a math major. Okay. Maybe that's why we're nice to the math majors.
Bias.
Yeah. Yeah, like if you can't get ahead authentically, just cheat, right? Chat, don't clip that. Wait, what? Yeah. Okay. So there you go. You can do this, or you can do that, or you can do whatever you want. Okay, so I think we were all having fun doing that, right? That was probably pretty fun.
Oh yeah.
What happens? Hear me out. What happens if we don't always want to rotate by the same amount?
Rand ins?
Oh, I was just gonna hit it with an offset.
Oh.
And I think, wait, didn't Offset get inducted into the Rock and Roll Hall of Fame like yesterday? Is Offset in? I don't understand hip hop well enough.
Outcast.
Yeah, because Offset's not an Outcast. Who's an Outcast? Andre and. No, Offset's in Migos, right? Yeah, okay, so you're not your head. Okay, so and Migos is not in the Rock and Roll Hall of Fame. Okay. Who's the second person in Outkast who's not Andre? Who's other than 3K? Okay, this is. I shouldn't have to know these things. Big Boy, right? Of course, right? I should get sued for that. Okay, what were we doing? Oh, we were doing modular arithmetic. See, so this is how we solve the modular arithmetic problem, and then. Here, have I say, percent equal length of the alphabet. That's the same thing as all of this. You can do whatever you want. Cool. So that was fun. Let's throw an offset in there. Okay, who else is in Migos? So Offset's in Migos. There's only 3 of them, right?
2 now. 1 died like a year ago.
Yeah, though probably is still considered a member.
Take off.
Yeah,
Offset.
take off Offset. Okay, you gave 1 away. And then who's the 3rd one? Well, I should have known Offset's name because he's referenced in like all those Cardi songs. None of which I can say in class. Okay, Quavo. Is that?
Yeah.
Yeah. Yes.
Just looked it up.
Partial credit. Okay. What were we doing? We had offsets, right? Just like stir fry or motorsport. Okay, so put the offset in here. This no longer works because we're not providing an offset. Let's put in an offset of 3. Then it behaves the same way as the original cipher. What happens if I put in an offset of -7? Okay, so you got the z, right? The z's at the end. And then you got the y. That's -6. X, -5. W, -4. V, -3. Is it S or is it T? Okay, it's S. We did it, team. And then what do we do? Of course, we make sure we can go back around the other way of the alphabet, right? I think that's right. Is that right?
Yeah.
How do we know that's right? Oh, because the letter after S and we did Z. So this should be the letter after T. U. V. W. Okay, all right. So, anyways, this is how rotates work. Why is this useful? This is a component of the next assignment. We can now encrypt and decrypt. How am I going to do this? I'm going to write simple functions that encrypt and decrypt. So, I'm going to def encrypt by taking a letter, and I'm going to rotate that letter by 17, and then I can def decrypt a letter, and I can rotate that letter by -17. I can have a secret. My secret is what my favorite letter of the alphabet is, which is M for Marshall Mathers. Okay, and then I'm going to encrypt that, which is going to be the cipher, which is going to be encrypt of M. And then I'm going to have, I don't know, output, which is going to be the decrypt of the cipher. And then I'm going to print those out. Secret, cipher, output. Oh, something exploded. Oh, I'm not returning. Okay, you write your return statements. There we go. It appears that maybe something went wrong. Oh, I don't have a negative here. Boom! MDM. Oh, I should have done it so it was MNM. Hold on. Is N before or after M in the alphabet? L, M, N? Oh, it's M&M! Yeah, but, right? Okay. I've got those cultural references. People often say, wow, Calvin, you have such cultural references. That's what they say to me. Okay, so there we did it. That's rotations. This, by the way, fun fact, this only works on letters. So if you want to do this to, like, bag of Lay's, first of all, there's, like, a period and a space and lowercase letters in there and stuff. But we can probably do this to encrypt word, which we take a word, and then what do? Let's see. We're going to make a new word. It's going to be nothing. And then we're going to do new word plus equals. Okay, and then we're going to do that. 4-letter in word. Encrypt letter. And then we can do the same thing for decrypt word. Decrypt. And then what's wrong with this code? Did someone say no return statements? Huge W. Or, well, we don't know it's a W, right, because we haven't encrypted it or decrypted it. But there could be a huge W in there, right? Yeah. So well done. A+. Return new word. Return new word. Anyone have a word we want to encrypt? Wait, did I not get the print statement? There it is. And is this going to work? No, because my encrypt and decrypt are single letter functions. You completely played yourself. You've been bamboozled. I've outsmarted you. Nope. You outsmarted us. So a lot of people know me by my stage name, Dibwimijubio. That's not a very cool stage name. Kind of want a cooler stage name. Yeah, like there's almost a DJ in there, right?
You do like Cinder, and then the first one would be no.
Oh, wait, what?
If you go back to what your offset was before, and you did Cinder, you would have DJ something because C goes to
Yes.
goes to J.
So the final boss of Dark Souls 1 and 3 would have a cool name, and I wouldn't.
Yes.
We already knew that.
And also like PS1 kind of sort of.
Hans. I don't know. Well, anyways, we're having fun, but perhaps too much fun. So go ahead and stop having fun. Put all of your fun away. Remember you're a little kid and you had to like put the toys away at the end of your play session, right? I've never recovered from the emotional damage of that. I just stopped playing, right? And that's why I don't play. Okay, all right. I'm like an MP3 file that's corrupted. Okay, so, by the way, you can also just do this by manually creating new ciphers. So if you know what offset you want to use, well, all of this stuff we did up here, that helps if you're specifically trying to do an offset, but you can also just make a cipher. So I'm going to make a big C cipher, and it's going to be ABCs starting at 3 and going to the end, and then going up to 3. And that's going to look like this. Okay, right? And then, rather than doing a sort of classical sort of manual rotate, right? I can just do the reversal where I was using indices. So we'll do by index. I'm going to take a letter, and I'm going to do what? I'm going to look up the index of the letter in the alphabet. So I is going to be abcs.index letter. And then I'm going to return the cipher of the index. And this is going to be basically the same thing as a rotate by 3, which I'm going to demonstrate by taking a letter. We'll take my favorite letter, which is T, and then we will rotate letter by 3, and then we will also by index letter. And those are both W's. Huge W's even, right? Enormous W's. Why is that? Well, this is getting a little small, a little cramped, a little hard to see. All we're doing with rotate is we're really just treating ABCs like it's starting at a different number. And instead of treating the ABCs like it's starting at a different number, we can just make a version of the ABCs that starts at a different letter, right? That's the same thing. And so when we run this, we're basically just using this as a way to encrypt our letters, okay? Now, it might seem a little sketchy, but it's going to get a lot sketchier, so hold on. Okay. You don't have to put all of the letters in the alphabet in order. So some of you may have heard of the Nazis. Can I get some loud booing?
Boo!
So when the Nazis were doing their thing they did in, like, the 40s, I might be making this up, they had U-boats.
Oh, okay.
Okay, I don't know where you thought I was going.
You started with the things the Nazis did in the 40s, so there's a wide variety.
Yes, and none of them were good, right?
Yeah.
And so they didn't want people to read about them in plain text. Okay, all right. This is not good. We are not endorsing the Nazis. Okay. Specifically, we are endorsing defeating the Nazis. Okay.
All right.
It says on this slide, "Be gay, stop war crime." Okay, all right.
They made a movie about that.
Yes, and it had Keira Knightley and other people in it. Presumably, I only noticed Keira Knightley. But it's kind of like, imagine you like show up to your first day at the office and you're like, "Oh, I'm pretty cool. Oh, I'm Benedict Cumberbatch." They're like, "I wonder who my co-star is," and you're like, "Oh, they could have cast like a mannequin, right? Like, how would we know?" And then he played a mannequin. So okay, we're referring to The Imitation Game for those of you that want to watch it. Okay. These are 3 historically significant rotations, or ciphers, or whatever they are. What are they? These are the ones that Alan Turing, queer icon. So one of the great things about World War II is there's like the side you very obviously root against, right? The Nazis, right? And who defeated the Nazis? The British Empire that then killed Alan Turing for being gay. So, like, maybe there were just 2 bad sides. But anyways, and I don't know if they officially killed him or not, but in fact, like, that did happen. Okay, so, anyways, these are the ciphers that Alan Turing figured out by apparently staring at code. Now, fun fact about Alan Turing. Alan Turing and I have one thing in common, which was we both attended university in the United States. Yeah, crazy, right? That's all. And then, what's the other thing about Alan Turing? Okay, so nominally, I don't know if this is true. Alan Turing's parents were huge nerds, and they raised him not using the decimal number system. So they taught him all of the number systems at the same time. So you know how, like, the children of linguists all know, like, 8 languages because their parents are linguists, right? So they taught Alan Turing, like, binary and a bunch of other stuff. And allegedly, I can't find a citation on this, allegedly computers work in binary because Alan Turing just, like, rolled up to the computer engineers at some point and was like, why are you using decimal? They don't have fingers. And, like, no one had a good answer for that. So anyways, that's what I know about Alan Turing. Anyways, so we're going to give you these in Project 4. You didn't believe me, right? Boom! They're there. Look at that. Take a look at that. Yeah, cool. And there you go. There's prose, lengthy prose about them. Okay. So we got some ciphers here. I wonder if we can can I hit a copy-paste angle on this thing? Maybe just put it in here as cipher. Wait, did I destroy my computer? Oh, chat. Oh no, chat. Chat, I'm cooked. I'm not cooking at all. Okay, Bizcode. We're back. Did you see how long it took for the syntax highlighting to turn on? My computer is giving up. Okay. How is that what I copied? Okay, copy. There we go. Okay. And what's that? Okay. Oops, by index isn't being applied to anything. Okay, not to worry. I have a plan. Letter. Okay. So, what's going on here is, we'll run this again. Or am I printing the cipher? Printing the cipher. Okay. So, I have no idea where that W is coming from. Presumably I'm printing something way up here. There it is. There's a rotate. Okay, so take a look at the cipher. I put a T, and what do I get out? P. Why is that? Well, we should print not just the cipher, but we should also print the ABCs. And if we do that, and then we see that our letter is T, we can look over here and we can find T in the ABCs. And we can see that directly beneath that T, there is a P. So that is the transformation I am applying. That's kind of cool, right? So say you're fighting a world war in the 40s, right? And you maybe don't have computers yet. You can also just, like, make a gizmo that does this, right? The only thing you need is for example, if you have a typewriter, you can key up the typewriter so that when you press a T, a P comes out. That is within your abilities as someone just doing mechanics, right? Let's put in another letter and test it. I'm going to put in A first because that's the most obvious. So A lines up on top of E, so we get an E out. Let's check J, and we should get a Z. Somewhat surprisingly, if we put in a Z, we also get a J, so we can check that. Z, J, and that's the J. This works with other ciphers as well. Here's another one. Let's see. If we put in Z, we get E. I'm going to print letter as well, so I'm nervous about it. Not what I meant to do. Okay. Z is above E. If we input a Z, we get an E out. Let's try K. We should get an L. Run. There we go. K is above L, so we putting K and we get an L out. What happens if we put in L? We get H, whereas L in the alphabet right here, so then we get H afterwards. Okay, so this is how we apply ciphers. And then if you're an uber turbo genius and you just like look at a bunch of Nazi war messages, eventually you realize this is what's happening to them. I guess that's the story of the imitation game. So, this is how we can perform relatively simple encryption. This was broken without the use of computers, actually. And then more advanced ones required the use of computers. So, you will probably want to use something like this on the project. And I'm providing these things to you as a way to take a cipher and a letter and get back the encrypted letter and then also the decrypted letter as well. Okay. This was cool and fun. Right. Oh, one other thing I should emphasize on this slide. We should do both encryption and decryption, so I am going to do that now. I'm not going to skip that. How many minutes do I have? 15? Okay, that's fine. So I'm going to get rid of a bunch of the stuff up here, but I'm going to keep ABCs and I'm going to keep the cipher. Okay. This by index, this is now just encrypt. Encrypt. And we're going to change that to testing encrypt, and we'll make sure it still works. Crypt. I don't know. So I thought like a crypt is like where you live once you're dead. I don't know if there's any relation to that. Like these letters are still very much alive. Or like they're as alive as they were before we encrypted them, right? We're not like, you wouldn't say, oh, I entombed that letter. So I don't know why we use the term crypt. But there's also cryptic, right? So like this is a word. And I don't know the etymology of cryptic. Minute cryptic? Ooh. Black sheep beginning to moo if it's confused? Sorry, it's time for a brain break. I don't know how to play this game. Has anyone ever played Minute Cryptic? Bovine. Check. Hints. I don't know. We're getting out of there. Someone play Minute Cryptic and then come back on Friday and tell us how to play it. We'll play it as a class, okay? All right. So, what are we doing? We're going to encrypt something, so we can encrypt the letter, right? How do we decrypt it? So our cipher, cipher's already used. I don't know. Cryptid is going to be encrypt letter. Cryptid. Okay. And then we need to decrypt. So how are we going to decrypt? Watch this. This is going to blow our minds clean out of our noggins, right? I'm just going to change where the ABCs in the cipher are. I'm going to leave everything else the same. Watch this. This is wild, okay? Change this to decrypt. Change this to cipher. Change this to ABCs. I know what you're thinking. You're thinking, no way will that work, right? So I have to get an L back from that H. Can I do it? We're going to call this maybe. We're going to decrypt the cryptid. And then we're going to print maybe. Folks. That's why the Nazis lost the war. And there was a number of material factors as well. For example, that fascism is inherently destructive. But anyways, I guess this helped, right? Okay, so there you have it. Why is this useful? You have to do this on the assignment. Okay, so there we go. Let's take a look at the code. I got completely owned by this assignment because I couldn't understand the instructions, but it seemed easy once I did it. So this makes me nervous in that I think the hard part of this might be to understand what we're asking you to do and not to actually write the code. Let me show you what we've got here. Can I open this in the old Firefox? I don't know how VS Code works. Open with Firefox? Okay. How do you all open it?
I just drag it under.
Oh, you. Oh, that was probably supposed to work.
Like to the top.
To the top.
Wow.
You all can do whatever you want. I typed open.
Wrong instructions?
There's not that many instructions.
That's the wrong instructions, though.
This is the wrong instructions?
That's the term.
Oh, because I'm in Dash. That would make sense, right? Do you see how Dash is over here?
Yeah.
That's crazy. All that work. Hold on, I have a plan. Oh, wait, did the click not work? Okay, hold on. It's possible. Okay, folks, we're going through it, is what we're doing. Let's see if I'm clever enough to do something here. Okay, there we go. You can usually find these on the internet if you need to. Now, do not be alarmed that says Monday the 18th. The reason I found this is because these are last year's instructions, right? So don't worry about it. Okay, there are 3 versions of the instructions. There's my version, there's Professor Eric Roberts, and Professor Jed Rembold's, okay? What is my screen doing? Okay, so here is the Eric Roberts instructions. Why are these useful? This one is animated. That might be super useful to you. And I think if you press like one of these buttons, it shows you stuff going on the inside of Enigma. Okay, so you might want to use this. Okay, and then there's the Jed Rembold version. I think there might be a new version of this later. This is probably last year's version, so you can take a look at these as well. Okay, and then there are my instructions, okay? I'm going to follow my instructions because they make sense to me. So what are you going to do? You're going to, did I open the classroom code? Oh, I didn't accept it yet, that's why. No, I totally accepted it. Okay, we're going to download this. Download zip. Okay, where is it? Open with VS Code. There we go. There we go. Okay. All right. So, a lot of stuff, right? A lot of stuff. That's okay. Don't worry. You only work in model, I think. Is that right? Let's check. So, like, what even happened there? Okay. Remember, like in Wordle, where like we just gave you some code up front, and you just pressed a button, and then like a bunch of stuff popped up, but it wasn't done yet. Mm-hmm. That's how Enigma works. So, there's a bunch of stuff here, and it doesn't work yet. I can't click on things. Nothing is clickly, but I can start adding code to this, right? And so if I look at one of the milestones, I want to collapse this. A milestone 0, I updated key pressed, key released, and is key down. Okay, why did I do that? I don't know, probably because that's what the instructions say. So let's take a look at the instructions. Where did I drag this?
Don't you already have them open?
Well, I have the wrong ones open, don't I? Okay, we'll just use these ones. Okay. So let's look at this. Okay. So most of these assignments, I didn't know the best way to document them. I broke them into sub-milestones. And the reason I'm calling them sub-milestones instead of making my own milestones, I want your milestones to be the same as the milestones in the other sections so when you talk to your section leaders. So I gave you internal milestones that you can use or not use. That was for my description. All of this is based on, so I basically did this without instructions, and then I wrote my instructions from the notes. Okay. Key pressed is basically a listener, like click action. In it, you'll want to take the provided argument letter and store it. Okay, well, I can probably try that. So let's see. Key pressed. Let's go ahead and print letter. Okay. Oh, is it up? Okay. Print letter. Okay, I'm going to try and click A. Okay, there's A's. There's D's. And it may pay to get A's, but D's get degrees. That's not true. C's get degrees. D's are a little bit sketchy. Try and avoid getting D's. Speaking of C's, there you go. And what do L's get? I don't know. Lampreys.
Printing 5 of them at a time.
Oh, I'm clicking it a bunch of times. Sorry. I'm going to press K once. That's me. Okay. I'm pressing O once. Okay. All right. That was fun. Everyone having a good time?
Mm-hmm.
Yep. A lot of people don't know this time is actually short for Timothy, the full legal name of time. Okay. And it's spelled this way. Yep. I'm sorry, I don't make the rules. Okay. The most obvious place to store the letters within the Enigma model class. Okay. So what am I going to do? I'm going to say self.letter equals letter. Easy. Okay. I tested key pressed by printing letter along with a note that the print was coming from inside the key pressed function. That sounds fun. Okay. Key released is also a letter. A listener. I used it to change the stored key value to none to note that a key was no longer pressed. Okay, that looks easy. Self.letter equals none. Okay. Is key down is a method that takes a letter and returns a boolean. Oh, that's crazy. Where is that? Is key down? Okay. Return letter is self.letter. Okay. Oh, whoa, what? Sorry, do you see that? It's changing color. Why is it changing color? Because the gobs of text in this other file are checking, they're asking, is letter pressed? And then they're updating the colors accordingly. So all of that stuff is coded in already. So some of the, see, it's red. It might be hard to see. By the way, you can break it by dragging the click off the screen so it doesn't generate a key released action. That's just that's a little fun fact for you. So some of the things on the milestones, they might ask you to do things that like seem confusing or don't make sense, or why am I writing is key pressed? Well, there's other code running somewhere else that is checking to see if keys are pressed. That's why we asked you to write it. So maybe that will make things make a little more sense, and that's why I wanted to show you milestone 0 right now. I'm not going to literally give you the code for milestone 0. That is sketchy, but I did in fact write it in front of you and record the whole thing. Okay. Once you're doing this, so this is a mock-up of what the Enigma machine looks like. You're going to gradually go through the process of making this perform the same steps of encryption as the evil war technology. So that'll probably be fun. Start on this one early. People say it's hard. I don't know. Hopefully it's not that hard for you. And then ask questions in Discord if you get stuck. There's one last thing I want to show you. This is not super easy to find, but there's a link in the instructions, which you will have. I also taught Enigma in my cryptography class, and so I have some visuals for how to look at it. This may or may not be more clear to you. But all of the stuff I did today with ciphers, I broke all of that down. I show the examples of going through ciphers multiple times, which the Enigma machine does. There's a special cipher called the reflector that it doesn't matter which way you go through it, the same thing comes out. So if I put in a K, I get out an M, regardless if I do alphabet to reflector or reflector to alphabet. That's kind of crazy. And so here's an example. And then you go backwards through. You'll probably want to look at this when that happens. And then here's an end-to-end Enigma encryption. You'll notice that there's a lot of it. You go through 7 ciphers, but it's the 3, which we call fast, medium, and slow. You go forward through those. You go through the reflector. It doesn't matter which way. And then you go backwards through slow, medium, and fast. So that's fast, medium, slow, reflect, slow, medium, fast. It's like a in and out. And that reflects this thing. So I'm going to press a key down. A goes through slow, medium, fast, reflector, fast, medium, slow. And it follows back and then it goes out E. So that's what's going on there. The most confusing part of Enigma to me is rotors, which is not this one. It's rotate. The ciphers, when you're using the Enigma machine, they change over time, but they change by a rotational cipher, which is why I spent all that time teaching you rotations at the beginning of class. To me, it was really non-obvious how these rotations worked. Here's the best visual I can come up with to represent them. If you go forward through a cipher, it is a simple substitution. Easy. When you go through a rotated cipher, which is the very last milestone, do not worry about this until you're done with everything else. You can get a very high grade on this assignment without understanding this ever. You rotate the letter forward through the alphabet, throw it through the cipher, and then rotate it backwards through the alphabet. And you do this whether you're going forward or backward through the cipher. So how did I sketch this out? I don't know. I don't have a great way to do this. These are the rotational ciphers. These are the projection ciphers. But I put them in a huge box, and I showed an entire Enigma process going all the way through this with like tons of text. And everything's labeled. See, we went through the reflector, and we're going back to slow, medium, fast. So you might want to look at this or not. I don't know. I wrote this up right after I finished teaching the class last term. And it's 11:20. Ask questions if you have them. Talk to your section leaders.
Would it be smart if I found other smart people to work with?
Yeah.
Enigma?
Yeah.
Also, I looked at the etymology of crypto.